Okay, lastly, we have reached area between curve and axis. So using integration to find area, we'll always yield the area with the axis being one of the sides of the area found. Okay, be it y-axis or x-axis. Okay, to use integrate x dy, the area must be bounded by what and what must be expressed in terms of x. So let's first look at this. This bottom area here and this top area here can be found separately. The top area here is found by integrate bcy dx. Okay, because you are touching the y-axis, so it's dx. Okay, and your area is above. Now, when your area is below, you cannot just write down integrate a by dx, because the area is below. When you do this, the y values are all negative there. You integrate them, you get negative. But area cannot be negative. So you need to artificially put in a minus in yourself here. Okay. Therefore, the total area here, right, is negative integrate a by dx plus integrate bcy dx. So the total area, take note, the total area is not equals to integrate a to c of y dx, right? It's equals to this thing plus this thing separately. Okay, if not, your total area will be nullified by the negative area. Okay. If, on the other hand, you want to use the y-axis, the area is touching the y-axis, then you will integrate a b x dy if the area is on the right, because then x is positive. X is, values are there are positive. But if your x values are negative, then you must also put a negative here. So integrate negative, negative of integrate bc of x dy. Okay, so the blank here will be, if you want to use x dy, the area must be bounded by the y-axis, and x must be expressed in terms of y, so that you can do integration dy. To do dy here must be in terms of x. Sorry, in terms of y. If not, you cannot proceed with the integration. Okay, finding the floating areas. The general rule is to integrate top curve minus bottom curve dx. Doesn't matter where is the area, even if the area looks like that. This is top, this is bottom, right? You still just use integrate top minus bottom dx. Okay, but if you want to be more succinct in your working, you see that for this particular example, you can actually do integrate a b y dx, which will give you this whole area. Okay, this whole area. Then you minus area of trapezium. Alright. So on the other hand, if we look at the example on the right, if you choose to integrate a b x dy here, okay, since the setup is looks like we should integrate with respect to y, you need to know that you actually get this part, because the whenever you do integration, the area you get will always touch the axis. But that's not what you want. You want that floating part. So you can take the rectangle area minus this. Okay?